one of the big issues with doing it like this is that it's not. If you say, right, at time I don't know, 500. So we might have time 500, 501, 502. I know you can't read that, but you can trust me. That's what it says. We might hold this orange segment, which we'll say is core 3. 0, 1, 2, 3, da, 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 da. This is core 3. Well, it might be that we have purchased the right to define what happens at core 3 at time 500. All right? So for that 6-second time slot, we are the ones that can put forward a work package into core 3 and have it be executed. Now the problem is that what happens if the guarantor's feeling lazy and they don't manage to do it in time, or you don't manage to send it to them in time, or whatever. There's a lot of things that can go wrong with this kind of very synchronous model. Yeah. We need something that is a bit more forgiving. So rather than specifying that the work package for time 500 must actually get into core, be done on this core at time 500, what we do is we have a queuing system. So every work package, actually, I'm going to use a different whiteboard. Every work package has a queue of authorizers. And when this queue is full, well, basically every block, we take, what the authorizer of the new block, so this new authorizer, and we just insert it in. And if it pushes this last one off, so be it. We discard it. Yeah? So this has a maximum size. But most of the time, the guarantor will have put forward a work report whose package fulfills one of these guys. And when he does that, he pulls it off, gets rid of it. So the queue kind of drops one, and then the queue puts one on. And most of the time, one gets pulled out, one gets put on, nothing gets discarded. If for whatever reason no one's providing a work package, or there's something wrong with the guarantor or whatever, then we may end up dropping things off the end of the queue. It's like unfortunate, but that's just it's a best effort thing, right? What this means is that if for whatever reason, let's suppose we've got 2 different core time purchases for this core, and they're interleaved. So on odd blocks, it's or odd time slots, it's A. On even time slots, it's B. We're going to end up with something that looks like this: A, B, A, B, A, and so on. Yeah. So even ones, A gets put on, odd ones, B gets put on. Yeah, and they just keep getting added onto the queue. Now, if the guarantor sees a work package, then they, and generally they'll want to, they'll favor the work packages of these earlier ones. So suppose the guarantor has a work package from A, it fulfills the A authorization, then it pulls this one off, and on here goes B. And then the A work package works its way through, gets into state. Very happy. The next block, we see a B1 coming in, so it pulls B off. B gets to use that core. an A gets put onto the end. You can't see that, but there is an A there, trust me. In the case that there's something wrong and A, just for whatever reason, isn't producing anything, there are no work packages available, or if the guarantor is not very nice and they are always just favouring B's work packages over A's, then something like this will happen. So we have A, but for whatever reason, the guarantor, or either the guarantor isn't processing A's work packages or A isn't producing work packages, but it uses B. So B goes through, then we add A onto the end, and the next time it picks another B, and we add B onto the end. And then the next time it picks another B, and we add A onto the end. And then the next time it picks another B, we add B onto the end. And then the next time it picks another B, we add A onto the end. Now we're stuck because the guarantor, we only have A's. A. Yeah? What happens is the guarantor is forced to either not take a reward for producing a guarantee or picking an A. Now, if A isn't producing work packages, guarantors bang out of luck and they just cannot. A has wasted their money procuring this core, and the guarantor is, for a few blocks, not going to get paid for doing this guarantor work because there's nothing to guarantee. If it's the other way round, then A is bang out of luck because the guarantor's ignoring them, but on the other hand, the guarantor is giving up serious amounts of income by not doing the work that has been paid for. Yeah? And eventually, after 10 blocks, the guarantors will rotate, and it won't matter. It'll be a new guarantor, and presumably they will process this items in this queue. But crucially, B doesn't get any extra processing. And if for whatever reason either the guarantor works or they rotates and the new guarantor comes in and they're a good guarantor and they actually process the work packages, or if A actually, if they were the ones that weren't producing work packages, if they start producing work packages again, then they'll get all of their owed blocks up until some limit, which is the size of this queue, and I think that's 8. Yeah. So basically, the queue allows us this leeway, this helpful margin of error, in case the guarantor doesn't receive work packages, or the guarantor is broken, or whatever, or there's some latency. This queuing system allows us to work around that. The alternative, which is that, you just specify it for the block, and if you don't make it in on the block, then it just doesn't happen. That would be basically equivalent to a queue of length 0. But because we have a queue of length greater than 0, we have this margin of error that we allow ourselves. So that's what we do here. Now, this is the pool and the queue. So the queue is this. Sorry, I got it the wrong way around. The pool is this. The queue is basically this. So it's the queue is the thing that feeds into the pool. In this case, let's suppose would be B, A, B, A, B, A, and so on. And the queue is basically how you populate the pool. The queue is what you can set as a core time owner. And the queue is a fixed length, it's 80. Length is 80. And you can, by setting a new queue, you can basically create different things that work their way into the pool. So you can maybe, you have this one, and then maybe in the next 80, maybe C bought 80, C bought all of the slots in the next one. That wouldn't clear the pool, but it would start putting C's into the pool rather than pulling it from B's and A's. So the queue is kind of what is populating the pool, and the pool is what is determining has to happen on a core at any given time. And because the pool is more than one big, there is actually some potential for guarantors to select out of order. Work packages out of order. Yeah. So let's have a look at the formal. The formalism. So alpha here is the authorizer pool. And it is a sequence of sequences. The outer sequence is the number of cores. And the inner sequence is up to O hashes. Each hash is this authorizer agent function. Yeah. We have up to O. O is the size of the pool because it may not be full. Like at the Genesis block, it won't have anything in it. And then we kind of add stuff to it over time. Eventually, it should fill up, and it will just stay at O, but it won't necessarily. It won't start at O for sure. Our queue, this one, as I say, this is what feeds into alpha. Again, there's one of these for every core, and then for every core we have Q authorizers. So H is still just an authorizer hash, and there are Q of them. Yeah, Q is 80. O I think is 8. So this 8 is kind of how much margin of error, how much out of order we can handle. And then the 80 is basically the unit by which we set what will happen in the future, what authorizers are allowed in the future. And we do it 80 at a time. So that's 8 minutes. So it's sort of 8-minute blocks we set what will happen on a core. If we don't set anything new, then it will just be the last 8-minute queue section that repeats. So it kind of repeats until we set it to something new. And it's up to the core time service to do this setting of queues. It's not something that Jam cares about. Jam just expects it to be done. There is a special host call that the PVM, the accumulate PVM, has access to that allows for this to be set, to have its value changed. Yeah. And one would imagine that the parachains service will be privileged to do this, and it will only do it when the core time parachain has told it to do it. Yeah, so it's going to be a bit of a fiddly two-level thing. It's a bit odd because if you assume Jam is level 1, like layer 1, then the parachain's service is layer 2, and then a parachain would be layer 3. And then like a smart contract on a parachain would be above there. Right? So it was sort of layering quite deep. But for now, we're just considering Jam, layer 1. And as far as Jam is concerned, it's layer 2 and above that decide what these queues should be. It doesn't know anything about, core time, sales, or anything like this. It's just tell me what the queue is, says Jam. Don't tell me how you figured it out. Okay, so let's have a look at the state transition. So for every core, so every core index, so C goes from for every C for 0 to 1022 inclusive. Sorry, 340 inclusive. There's 341 cores. The posterior alpha is the rightmost O is 8, of the posterior, let's look at this right to left, because we're only keeping the rightmost, right? Of the posterior Q for this core at this time modulo. So we're going to work our way through the queue, one time slot at a time, and when we hit the end of the queue, we wrap around, go back to the beginning. For our core, and we're going to pop it on the right side. And then we're only going to keep the right-hand O elements, which means any that are left, if it happens to be too big, the one on the left will be dropped. So, but you'll notice it's not a simple expression. It's this function f of C. C is the core index. So what's f? F, I mean, I can already tell you what it should be. It should be the pool minus any item that we have used this block. Yeah? And let's have a look. F of C. If there is a work report submitted for this core, that's what this bit means. If there is a work report submitted for this core, then it is our previous pool configuration, removing the leftmost authorization that work report is using. So we drop the leftmost authorization. In this, I actually got it wrong here. I was dropping the rightmost. It's actually the leftmost. If there is no new work report for this core, then it's just the previous value of the pool. Yeah? So in the case that a core goes without a work report, we're eventually going to fill up its pool and then start dropping items off the left side. Yeah? That's what this means. But if a core has continuous work coming into it, then we won't be dropping anything, because we're going to be taking an item out and putting an item onto the end. Taking an item out, put an item onto the end. We're never gonna remove one and add one. We're never gonna overflow. Yeah. Good. All right. That's authorization.